Welcome, everyone. Let's get started. My name is Tim Erlin. I am the VP of Product for WallArm, and I'm glad that you're here to join us today for this session about our Q3 2025 API Threat Stats report. I'm joined today by Jake Jacob Smith, who is an AppSec engineering manager at Yext, and I'm thrilled to have an opportunity for this conversation with him. And from there, we'll get started. Jake, thank you for joining us.
Yeah, happy to be here. Thanks for inviting me.
So before I give Jake the chance to talk, I'm just going to tell you a little bit about the API Threat Stats report so that you have for those of you who aren't familiar, that you have the context for what we're talking about here. WallArm does these API Threat Stats reports on a quarterly basis, and then we do an annual roll up, looking at sort of the year in review, if you will. And they are focused on the API threat landscape. So we're looking really at what API threats have occurred or shown up in the last quarter and how the threat landscape has changed. I went back and counted, and I think this is the 15th report that we've done. So, they started maybe a little more humble and hopefully have improved over time as things have gone. And a little bit about the methodology here. Just to give you a sense of what we're doing, we start with data collection. The data collection is really an ongoing process that happens throughout the quarter, and then at the end of the quarter, we go and we analyze that data, filtering it for API specific data. We're pulling out the API vulnerabilities, if you will, and we're pulling out the API exploits, that kind of thing. We do some normalization, we do some classification and analysis to map the data back to the OWASP API top 10, for example. And then we ultimately produce that report. And we use a mix of AI for analysis as well as manual analysis and manual review to come up with the end results. And the reason that we produce this report, to be honest, we started doing this because we need the data for our product. So in order to build a better product, we have to stay up to date with the threat landscape. That sort of ability to build the features and capabilities that address current threats is greatly improved by understanding what those current threats are. So that's what's behind the report. As we built that for ourselves, ultimately we decided it was worth sharing, and we started building or publishing the Threat Stats report is the right way to put it. So hopefully that gives folks a sense of what we're looking at. We'll talk a little bit more about where the data came from and what that data actually looks like for the quarter as we dive into the results. I will say if you have questions as we go, feel free to, we're actually broadcasting this on both Zoom and LinkedIn. So feel free to put your questions into the Zoom Q&A, or if you're on LinkedIn, feel free to put them into the comments and we'll pull those questions out as best we can and answer them either along the way or at the end. So with that, let's start taking a look at the actual results that we came up with. This is the sort of executive summary infographic that highlights some of the key metrics or key statistics out of the report. We saw that there were a little over 1,600 API-related vulnerabilities that were disclosed in Q3. That's an increase of 20% from the prior quarter. One of the things that jumped out at us in our analysis as we broke those down into specific categories, and then we did some special breakdown around AI-related API vulnerabilities, is that we saw a huge jump in MCP vulnerabilities as a percentage, up 270% from Q2 to Q3 as well. And that corresponds to the overall increase in AI API vulnerabilities of 57% from Q2 to Q3. So that gives you a high level. And Jake, I think my first question for you is, at this high level, are there any of these metrics that jump out at you as particularly interesting or surprising, maybe?
Yeah, I think it's really interesting to see this 20% increase. Personally, I think this is really just the tip of the iceberg. I think this
Mm,
is an indication of where threats are continuing to go, as we've seen threat services increase due to use of AI technologies, use of trying to just be more API first, as we see most companies are trying to do now. We're going to continue to
yeah.
see people connecting to things that they don't truly understand just to try to keep up with the trends.
It's interesting that you point out that 20% is the interesting metric here, because I thought you would jump to that big number that we put in the middle, that we clearly felt was the most important because we made it the largest font. Um,
Sure. And
it's
I will
interesting
say
because,
that, oh, sorry.
yeah, go ahead. No, please, Jake.
No, I was going to say that obviously the 270 is a very interesting number, but to me, I think anyone that's really been paying attention to this technology because it's so new, this is kind of expected. People are starting to play
Mhm.
with these technologies they don't understand, so we're going to see a lot of vulnerabilities as the technologies evolve and people start to use them differently.
Yeah,
So I see that more as kind of industry standard at this point. The 20% for me is really what stands out because we see more of an
yeah.
overall attack surface increase.
And I think you're maybe unintentionally pointing out one of the limitations in the report by saying that 20% seems like it might be a little low, which is that ultimately we're doing analysis on published vulnerabilities because we can't analyze unpublished vulnerabilities. The data is not available. And so the balance of APIs that are productized enough, I mean, I think it's a blurry line, but productized enough that someone might actually create a CVE or a vulnerability advisory for them is a subset of the overall threat landscape. And so that 20% could be misrepresenting the total in that sense.
I totally agree. And I do think that, like I said, we're going to continue to see these numbers rise pretty quickly. I think even just looking at these quarter by quarter, it's not even a small enough snapshot to really quantify how quickly things are changing and the results we're actually seeing.
Yeah, yeah, absolutely. So let's dive into some of the details a little bit further. We did in one of the things that we tend to do in these reports is we pull out sort of a what I call a threat stats spotlight. And in this one, we decided to focus on business logic abuse. So I want to start just with a little bit of context for everybody about what we mean when we say business logic abuse. And I put up some definitions up here to give examples. I don't want to read through them because that's usually boring. But from your perspective, Jake, what do you see as the difference between sort of classic vulnerabilities and business logic abuse? Is that a meaningful distinction for you?
Yeah, I think that's a perfect distinction. I really love that you guys called this out because I think that this is the most important area that my security team is focused on right now. I feel like for a long time, we've really been focused on what you've called these traditional attacks, SQL injection, cross-site scripting, things like that. And I feel
Hmm.
like the community at large really does understand at least, how these attacks happen and how to mitigate them. Something that we're less focused on right now, it seems, is these business logic abuse scenarios where the attacker is using the platform as intended, just in a way that you didn't intend, like using multiple coupons, being able to check out before you fill up your cart, things that you didn't really think about the actual business flow. And so
Yeah.
these can actually have a much higher impact than, say, just a standard SQL injection. If someone can utilize coupons 100 times and then you end up having to pay them money, I mean, that's a pretty serious vulnerability.
Yeah, it's interesting. In focusing on business logic abuse, I didn't really think a lot about the what the right term is for the other vulnerabilities, traditional vulnerabilities, flaws in code, something like that. But there isn't really a good term there for us to use to distinguish between the two categories. Um, and I think you pointed out rightfully that business logic abuse fundamentally it's that the application is functioning as designed, but that design enables abuse. What's interesting to me about that is that I think there are different levels of business logic abuse, different levels of complexity. And so it's almost difficult to talk about it as a single category, but we need to because we need some way to have that conversation, as you said, with developers as they're building applications or as they're trying to remediate these vulnerabilities. So, in terms of business logic abuse, hopefully that's helpful from a definition standpoint. What we're talking about here are those flaws in how the application works or how it's designed that enable abuse, as opposed to flaws in code, developer mistakes in syntax, that kind of thing. And what we wanted to not introduce in the report, but talk about a little bit in this report is the OWASP Business Logic Top 10. So in the report itself, we explain a little bit about why we think business logic abuse needs a sort of a spotlight, some of the changes that have occurred in the threat landscape. But we refer back to the OWASP Business Logic Abuse Top 10, which is a relatively new top 10 list from OWASP that Wallarm and other researchers participated in creating. And the goal there is, as with other top 10 lists, to provide that common taxonomy, that common language for talking about these types of abuse or these types of vulnerabilities. And I have a couple of favorites from here that I think are particularly good examples. I don't know, Jake, if you have any favorites, but I'll start. One of my favorites is the missing transition validation, because it's a great example of um, a vulnerability that requires multiple steps. So it's not as simple as I'm sending an exploit, I get a response back. It's being able to skip a step in a workflow, skip the validation necessary to get from one step to another. So I think it fits really well the definition of business logic abuse. I think it's a good example. I don't know, Jake, are there any that jumped out at you in particular?
Yeah, there's two really. I think the action limit overrun is something that, a lot of people can easily understand when you're starting to learn about business logic abuse, like
Yeah.
the using coupons multiple times. I feel like that's the one that really kind of resonates with people because you can understand how that would flow. Personally, I really love the resource quota violation. I think of that as being able to like spam votes for your favorite dancer on Dancing with the Stars or whatever you're watching.
Yeah. Yeah.
And obviously, it's important. We need to make sure that we have the resource limits or
Yeah.
quota limits for our users.
But that's a great point. Like part of the purpose of having a business logic abuse top 10 is that it's technology agnostic. It's not built for APIs specifically or for Docker specifically. There are a lot of OWASP top 10s, a lot of them are technology specific. So that resource quota violation, you just gave an example of where it applies as a business logic abuse condition completely outside of APIs or outside of web applications. You're talking about a technology agnostic approach, spamming votes in that way. That's interesting. There's another one that I tend to point out, which is the artifact lifetime exploitation, because it's one that in the our bias tends to be my bias at least tends to be API centric. I understand how that works with APIs, but I can also remember how things that should have been timed out or removed as temporary files, short-lived things, also existed in the past with traditional, legacy web applications. So it's a type of abuse that isn't specific to, our current technology stack, if you will. Yeah. So in terms of where we're headed with business logic abuse, I mean, the conclusions that we came to in the report are up here of what we think is going to happen in the next next year, say, around business logic abuse. Jake, are there any of those conclusions that you think are particularly important to talk about?
Absolutely. I mean, I'm surprised we got this far without specifically talking about AI, but really, I I see that the reason we're seeing these business logic abuse vulnerabilities become much more prevalent is because AI assisted vulnerability machines, using ChatGPT to run attacks. Really, everyone can become a pretty proficient hacker just using these tools. So these more nuanced, tricky to find vulnerabilities are becoming much easier to find with these AI assisted tools. And I think we're just going to only see an increase in these.
Yeah, I think that's to me that's the most important one. I mean, maybe that's why it's number one. But that's the most important one because it changes the threat landscape in a meaningful way. It's not just that attackers can scale existing attacks more effectively. It's not just that attackers can create new exploits, new novel exploits. It's that ability to um, using AI chain exploits together in a way that they never could before, that required a human being to
Mhm.
think through what that next step might be, because it's not deterministic, and generative AI can help with that. So it's a big change that we'll see. I agree, growing as we move into the future. All right. So let's move off of that business logic focus and dive into some of the vulnerability trends specifically. So the data here, for what it's worth, just to provide that context, we pull all of the published CVEs and other vulnerability advisories that we can get our hands on, and that's the core data set for the analysis. Um, and so I'm going to put up a slide full of data that we can talk about here. At the top, you see that 1602 number. That represents a 20% increase over the previous quarter's count. And I'll point out here, for those of you who are paying particular attention, if you read last quarter's report, that Q2 number is different actually, because what we did for Q3 is we actually employed an improved mechanism for analysis that does a better job of categorizing the vulnerabilities. It also gives us this breakdown by protocol that we didn't have before, that I think is pretty interesting as well. Um, so Jake, we talked a little bit about that 20% increase being lower than or misrepresent, lower than reality, I guess is the way to put it. Is there, in terms of the data and the way that these 1602 break down, are there things here that you think are particularly worth pointing out?
I think it's interesting. What really stood out to me is when we look at the protocol breakdown here,
Yeah,
obviously there's a significant amount of REST protocol API. That's a huge attack surface, and that is to be expected. What I
yeah,
found really interesting is this AI API is already second. I mean, this is
yeah.
it's really interesting, and I think highlights really what we're seeing.
And I think, you're whether you intend to or not, you're pointing out an area where I think we can improve the analysis next time we do it. AI API is not really a true API protocol.
Right.
But we wanted to pull that out. We wanted to pull it out in order to perform the sort of the deeper dive on the AI API vulnerabilities, if you will.
Mhm.
So on the one hand, I completely agree with you. It's really interesting that it's number two, even though it's a distant number two from REST, because almost everything is REST. But I almost want to like slice it off and say, well, look at what the other protocols are that are, and remember, these are vulnerabilities, right? So this isn't
Mhm.
distribution of protocols by use, it's distribution of protocols by risk. It's
Mhm.
really interesting to me that SOAP ends up in that number three
That's what I was
spot.
going to say as well. Yeah, very interesting.
Yeah. Why do you think that's interesting?
Well, it's interesting that this is what could be considered a legacy API, and I'm sure there's some people on this call that may hate
For
calling it a
sure.
legacy API, but it really is. And the fact that there's still that significant of a number of vulnerabilities in that attack surface is very interesting in my opinion.
Yeah, and it's we don't have the data here, but Postman does a state of the API report, annual one, where they ask a question about API protocol usage in that report. And SOAP is not number two or number three. So what's interesting to me is when you put those two things together, you have uh, the risk representation from SOAP being much higher than the actual usage, the current usage by organizations, and that's an area where um, I think you can find risk because organizations aren't paying attention to their SOAP APIs, they're not building new ones, but at the same time there are vulnerabilities out there as well. Yeah. And I mean, I don't know about you, but WebSocket also fits into an almost legacy, just from I think WebSocket has more active development than SOAP, um, even based on that Postman data. Uh, but it's been around long enough that I think I would classify it as a legacy API protocol as well.
For sure.
Yeah, yeah. And GraphQL, and interestingly as well, um, I think it's important to point out that yes, that REST has that sort of 83%. It's the biggest representation. The distance between SOAP, WebSocket, GraphQL, gRPC, they're not that far apart, really. The percentage distribution goes from 1.6 to, 2.7 more or less. But they're all in the, 20s, 30s, 40s in terms of count of vulnerabilities. So I don't think there's a huge, it's almost worth talking about them as a single block of like, of risk, if you will.
Yeah, I'd absolutely agree.
Yeah. What about the OWASP distribution here? These OWASP categories that we have listed. Um, Anything jump out to you about the OWASP breakdown?
It obviously we can't ignore the big scary red bar there, and I think what it really highlights is what we were talking about earlier, is that a lot of companies, a lot of teams are still not really understanding the fundamentals of how to deploy these
Mm,
technologies. The fact that we have 605 for security misconfiguration there, and that's a pretty broad bucket, I would say, and we could definitely drill into that quite a
yeah.
bit. But it does show that, just a misconfiguration is because you don't totally understand either what you're deploying, how you're deploying, or how it's used. And so it just shows more about the trend of people using technologies they don't totally understand and not taking the time to really understand the attack vectors that they're introducing to themselves.
I think it's definitely a signal that that bucket is too broad, as you said.
Hmm.
It's a little bit too much of an outlier for my tastes, and I'd love to
Hmm.
actually understand how to break it down into categories that are a little bit more meaningful that we could actually do something about.
Hmm.
Um, I mean, I guess I should say I'm suspicious that they're not all misconfigurations as you're describing them in that bucket.
Hmm.
I,
Right.
yeah, go ahead, Jake.
I was just going to say, I totally agree. And I do think it would be it would be interesting to see that broken out. But just seeing like all the different types of misconfigurations, I do think it is worthwhile to have that bucket just again highlight that again, we need to focus on the fundamentals. We need to
Yeah.
make sure we're helping our teams understand the technologies they're using and how to best secure them.
Yeah. I can't help but point out that the following three categories, broken function level authorization, broken authentication, and broken object level authorization, they're all related to well, they're all related, right, to
Mhm.
authorization and authentication. So while they're separate categories, I think they speak to a common problem in API development and API deployment around those key functions.
Absolutely. And I think even if you take in the misconfiguration still, if you have the top four, you look at most API breaches aren't happening because of some new exotic attack vector. It's really because they're being deployed with weak configurations or failure to properly secure the access controls that you should have in place.
Well, and let's keep in mind because I always like to go back to, the data set that we're talking about. Ultimately, we're looking at published vulnerabilities and vulnerability advisories. So these are, by definition, commercial products that have been released. That means that somewhere there's a development team that built them, that's responsible for them, and that those authorization authentication functions should be, a core capability for whatever products are. It's not rocket science. These aren't new problems. I'm not saying it's easy to build, but I am saying, like, we've been dealing with authentication authorization for a long time. It's surprising that they still sit so high up in the list of flaws, at least to
I
me.
absolutely agree. Sorry, I don't mean to cut you off. I really think that what this points to is again that the fact that there's so many companies, so many teams that are trying to deploy this novel new technology that they only have a fleeting understanding of really sums up the problem here. We need the companies need to take time to really understand the technologies they're utilizing instead of just trying
Yeah.
to keep up with the trends.
Yeah. It's also an area where standardization could help, right? If you don't
Absolutely.
want everybody building their own authentication and authorization. That's not what the application does. It would be
Mhm.
interesting to, I don't know that we have the data to do it, but it would be interesting to break down those vulnerabilities based on the authentication and authorization mechanisms that the products are using. Like, are you seeing a cascading problem of a standard being vulnerable and then it cascading to a bunch of different products? Or is it that they all implemented their own and that created the problem there? I don't have an answer to it, but it's an interesting question.
Very interesting.
So let's dive a little bit deeper on the AI API vulnerability breakdown. So in this case, as I said, we pulled out all of the vulnerabilities that we could relate, the API vulnerabilities specifically that we could relate to APIs. And so it's not a true protocol category, or true protocol, but it gives us a way to examine some of that data a little bit differently. And then we did a further breakdown into, we'll just call them AI categories at the bottom there. And I think it's interesting. I might flip back and forth between these two slides for a second. So security misconfiguration stays at the top, broken function level authorization stays at the top, and then broken authentication stays at the top. So we're basically seeing the same breakdown in terms of OWASP categories here that we see for the APIs in general. I don't think a significant difference there, unless you see something I don't, Jake. You feel free to speak up.
No, I think
Yeah.
that's fair. I do
So,
think it's
yeah.
oh sorry, go
No, no,
ahead.
go ahead, please.
I was just going to say that it is interesting, looking at this data that we really see that I think it's almost 99% of AI vulnerabilities are API related. I mean, it just really shows that people using these models, these LLMs, agentic systems, they're exposed to their users and they're exposed via API. And so that is really the core of API security is AI security, is product security, and all of these
Yeah.
things are tied together.
So we did that analysis we did in our last annual report, specifically what
Mhm.
percentage of AI vulnerabilities are API related. And we
Mhm.
came back with 98.1%, I think it was 98.1 or 98.9. I
I
can't
remember it
remember
was
the
very
number.
close to 99.
Yeah, and we didn't repeat the analysis in this quarter's data. So we took just the breakdown of API vulnerabilities that are AI related. And I know it's maybe a subtle difference, but in theory, there could be a bunch of AI vulnerabilities that are not API related that showed up in the last 6 months, if you will. That would be a
Mhm.
surprising conclusion, but we'll look at it again at the in the annual report as we do that. Um, and then, I do think it's noteworthy that the OWASP breakdown for these AI API vulnerabilities isn't materially different from the overall API vulnerabilities. It tells me that they're suffering from the same problems that the API vulnerabilities, API applications are as well, if that makes sense.
Yeah, I think that's a really good point, and that a lot of people really see, AI, that we have to throw out the baby with the bathwater. We need to reconsider our security. We need to reconsider everything. And at the end of the day, we really don't. These are
Yeah.
the fundamental issues that we've always understood. We just need to understand how they apply to AI.
Yeah, in a lot of ways, the problems we have, the problems don't change as the technology changes. It's just that you have to apply security controls to those new technologies. And in this case, it's not even
Exactly.
new technology. It's again APIs. Yeah.
Mhm.
And this breakdown by AI category that we had here. So we did our best. I think there's some refinement we can apply here in the future to break it down into MCP, agentic AI, and then everything else, right? All the other
Mhm.
AI use cases, if you will, or AI apps. And we saw that growth on MCP, which Jake, you pointed out, seems like it's about what you would expect given the adoption. So not a surprising change if risk follows adoption, which I think makes sense.
Absolutely. I think you could find a pretty easy correlation if you just did a quick scrape of all of LinkedIn posts and just did a grep for whatever is the most common phrase. I think you would easily see that be the top category. Right now, we're seeing everyone talk about MCP. Everyone's interested in it. Everyone's trying to deploy it. Everyone's trying to look into it. Obviously, not everyone totally understands it. And so it makes perfect sense that we have this huge spike in
Sure.
vulnerabilities.
Yeah, yeah. And I wonder if we'll see that spike continue through the next, quarter or two, or if we'll see it plateau, as sort of adoption has plateaued as well. I don't know. It's a good question. Okay, so let's take a look. We'll shift from vulnerabilities to exploits. So now we're not talking about published vulnerabilities and advisories. We're talking about real world exploits that have occurred in the last quarter. And the way that we break this down is we look at essentially public disclosure date, because of course uh, some of these may have appeared earlier, but we got to talk about when we can actually see them and do the analysis. And in order to analyze the exploit trends, we're looking primarily at CISA's known exploited vulnerabilities catalog, which is a limited set, but at least gives us a sense of what the trends look like. So we want to make sure that we're analyzing a data set that can be consistent year over year or quarter over quarter, and gives us an indication of where things break down. Uh, and so just at a high level, in Q2, there were 59 vulnerabilities added to the CISA known exploited vulnerabilities catalog. 13 of them were API related. That's roughly 20%. In Q3, that number went down from 59 to 51. So fewer total vulnerabilities added, which is interesting, maybe. And eight of them were API related, which is roughly 16%. So we actually saw a decrease in the known exploited vulnerabilities overall, from that catalog. And I'm not sure what conclusion to draw from that exactly. I don't know, Jake, if you had any particular thoughts about it, feel free to share them.
Yeah, I think the interesting thing here is that I see the message is that the threat isn't necessarily decreasing. It's just that the threat is more stable. API
Hmm.
security, it's not a new or emerging threat vector. It's a primary consistent vector for high priority in the wild threats that we're still seeing. I think it'd be unrealistic to continue to see it growing and growing and growing, but the fact that we're still seeing a stable, consistent number for the most part, I think is telling.
Yeah, and I'm not sure that that decrease is particularly material. I think a broader analysis of whether there's some a cyclical nature there, or whether even changes at CISA have changed their reporting in some way. I think there are interesting possibilities there, but it is clear that the API related exploits still remain a significant part of the overall exploit environment.
Absolutely.
Yeah. So we pulled out, since there are eight of them, you can put them on one slide. We pulled out those exploits just to give you, or exploited vulnerabilities is maybe the most accurate way to put it, to give you a sense of what this looks like, right? So again, we're talking about published CVEs that have been reported as actively exploited in the wild. And there are a couple names you recognize probably, and a couple that you might not. Certainly an exploit in sudo is um, a well known tool. Fortra's well known. Cisco's well known. Some of the others are a little less well known. I don't know that there's a specific um, conclusion to draw from the list of exploits or a specific trend other than that they're all API related.
Yeah, I think when we really look at them, we can see a trend for broken authentication and security misconfigurations, just like we were seeing before.
Sure.
It's a lot of these like fundamentals that a lot of times that this really comes down to.
Yeah, yeah. Yeah, there are obviously it makes sense that the OWASP categories for the exploits would match the OWASP category breakdown for the vulnerabilities, at least in some way.
Right.
Definitely. Yeah. Cool. So let's talk about breaches. The way that I tend to think about the data set that we look at as a whole is that this is kind of a trifecta, if you will, of vulnerabilities, um, known exploits or exploit trends, and then breaches, which are kind of the real world result of the other two data sets, if you will. So we're looking at risk realized, and then at the sort of real world impact um, of those risks that are realized. It's helpful to look at because it gives us a chance to learn some lessons from, publicly available breach data. Nobody wants to be the victim of a breach. I think every organization has that potential. And we certainly don't bring up these incidents as a means to shame the organizations. We bring them up as an opportunity to learn something from them. And so in Q3, we pulled out the top five API related breaches that we could find that we saw in the public. And I think there are lessons to be learned from all of them. Um, Jake, were there any of these that stood out to you as a particularly important, had something to teach, if you will?
Absolutely. Yeah, this time I'll take the softball, and with the number one rank, I mean, drift is obviously extremely important, and I'm glad it's ranked number one because it wasn't really the initial breach itself; it's the breadth of the impact. And
Yeah.
this is a true trust chain attack, and the abused tokens allowed attackers to access Salesforce APIs across multiple enterprises. I mean, it became a very, very big breach, um, and I think it's definitely worth looking at.
Yeah, and I agree with you. I mean, obviously we ranked it as number one. One of the challenges with that one is that we don't actually know, at least the last time I looked, we don't actually know how those OAuth tokens were initially compromised. And we don't know if it's one token that was improperly scoped or, individual tokens for all of the affected organizations. The fact that there were so many affected organizations leads one maybe to believe that it was a single token that provided access that was improperly scoped. But regardless, it's an API breach that, as you said, cascaded across multiple organizations and gets ranked number one because of that breadth. And it reminds us that the integrations that we deploy that are designed to be simple to deploy can have a far-reaching impact if they're compromised. So I mean, if you're looking at that, thinking about, giving advice on what cybersecurity practitioners should do, given the lessons from that breach, what's top of mind for you?
I think it really highlights again the fact of the trust excuse me, trust chains and supply chain attack. It's really
Hmm.
important to understand where you're integrated, how you're receiving data, how your data is being integrated into other systems, and to really understand how your systems, work with other platforms outside of your control, and really making sure you
Yeah.
have an easy way to indicate any compromises, anything out of the usual. Make sure your SOC is prepared to key in on that.
Yeah. And it's a tough one because the integration is between SalesLoft and Salesforce. So your ability to monitor that interaction is limited. It's not traversing
Exactly.
your infrastructure. And so you have to monitor it from, maybe from the Salesforce side. But I don't know that any of these organizations are the ones that actually flag that as a breach at the time. I'd have to go back. It would be interesting to go back and look at exactly how it was revealed initially. I don't remember.
Yeah, I'm not sure. I don't
Yeah.
recall.
So there are, however, four other incidents that occurred here, all of which have something to teach us. I want to point out number four, which is it's a tricky one to attribute in the sense that the attack or the compromise was with Paradox, which is an AI chatbot built around recruiting, but the victim impacted was McDonald's. So again, it's essentially a supply chain or a partnership breach where you had an AI interface providing sensitive applicant and HR data for a particular company, in this case, McDonald's, which exposed millions of applicant records. And so it's a significant impact for that organization as well. And it's an example. I pull it out because it's an example of where, AI is providing an interface for attackers that they didn't have before, and an attack vector they didn't have before. Yeah,
Exactly. I'm glad you called that one out. That was the second most interesting to me in showing that attackers are already targeting these AI chatbots. And it is a new area that we don't totally understand a lot of times, and we need to make sure we have pretty rigorous protections around.
yeah, yeah. The other one, given the conversation we had about business logic abuse, the other one I want to point out is the RBI Restaurant Brands International. They own Burger King, Tim Hortons, Popeyes, and Firehouse Subs. So sort of a conglomerate collection of fast food chains, if you will. And the reason that one's interesting is because um, it was actually multiple different vulnerabilities that can be categorized under the business logic abuse top 10 that occurred that allowed the attackers or the researchers in this case to ultimately get access to the audio recordings from drive-through interactions. But there was built in there was some BOLA, there was some missing transition validation, if I remember correctly. There was a GraphQL endpoint that was that allowed introspection queries, which got them information they needed for another approach. And then there was also a unauthenticated API that gave you the ability to create tokens that you could use to authenticate to other functions, which I thought was very interesting. It's a reminder to me that the developers may siloed developers may execute on their own individual tasks without understanding the whole of the system that they're creating, and you end up with these interactions between functions that an attacker can leverage.
Absolutely. And like you mentioned before, if we look at the buckets of traditional vulnerabilities versus, business logic abilities, no traditional scanner would be able to catch this. This is a much more nuanced vulnerability type that is the attackers using the system the way it was designed.
Yeah,
They
yeah,
just the protections weren't in place. And so this is really highlights how important it is to step away from thinking about just the traditional code level vulnerabilities and thinking about how your business logic can be used.
yeah, yeah. I think that makes a lot of sense. Agreed, agreed. So I'll fill in the last two that we haven't talked about because I still think they're important, even though we didn't choose to highlight them in particular. So Swissborg is a fintech crypto company that had a partner API that or a partner that abused their API, if I remember correctly. Ultimately, it resulted in $41 million being stolen. So it's a very quantifiable breach from a partner. So you're seeing a theme, with SalesLoft, with Paradox, with Swissborg, and also with FlexPay, which is another partner integration that was exploited to steal $168,000. So a little bit less, but still notable. So there's definitely a theme running through these five that focuses on partner integrations and partner use of APIs. And as we know, APIs are built for integration use cases, so it does make sense, but it is something, a trend to pay attention to, if you will. Yeah. Awesome. So did I skip? Yep. Okay, great. Let's talk about key takeaways. So we've kind of covered the high level of the report as a whole, the three sort of major sections plus the spotlight. Jake, having looked at that data, what are the key takeaways that jump out for you? And you can even ignore the ones that are on the slide if you want and come up with your own.
Sure. Yeah, really for me, the biggest highlights here is that the The attack surface is changing very, very rapidly. And a lot of security teams don't have the manpower or time to really keep up with these. I'm sure I'm not the only security team that is getting messages constantly about new AI tools that, the business wants to integrate into the product. And it's very, very difficult to correctly review all of these and make sure that protections are in place. And so it's really important to make sure that you understand where your data is going, who's controlling your data, like we mentioned with the trust chains and supply chain attacks. It's really, really important to be able to look out for anomalies and understand what data is being sent to vendors that you don't necessarily trust and what data you're receiving from vendors you may not necessarily trust.
Mm. It's interesting to me that you bring it back to data because I think we can often get caught up in the technology, but ultimately, as you're pointing out, what we're trying to protect is data. It's data that
Mhm.
we have or data that's being shared with us or data that we're sharing with someone else, and the technology is just a mechanism for doing that.
Mhm.
Yeah.
Yep, absolutely. And I do think it's also important to point out that I really like the focus on business logic abuse here because I see that as the biggest threat now. Like I mentioned, anyone can really work on these really nuanced, more hard to find vulnerabilities now. These, the traditional SQL injections, things like that, very, very important. But now anyone with a computer and access to ChatGPT can craft a very sophisticated payload and can find some very nuanced business logic vulnerabilities. And I think it's something that we're going to
Yeah.
continue to see and that we need to be on the lookout for.
Well, so let's drill into that one for a little bit because we've got it up here at number three. Business logic abuse is emerging as a leading threat.
Mhm.
Um, but what are we supposed to do about it, right? If we're a practitioner, it's all well and good to say, okay, this is a new threat. But when I go to work tomorrow, what changes can I make to materially address that threat?
To me, I see this as the importance of security teams and product engineering working closely together. A lot of times, security teams, product engineering can kind of be in their own silos, focused on their own
Mm,
things. This is where it's extremely important for any new integrations, any new development to really be talked through with security. There's a lot of really interesting tools out there that can assist in this, but at the end of the day, security needs to better understand the business flow, the business logic flows, what's supposed to be happening, and help the product engineering teams kind of talk through the attacker side of it. Well, what if I did this? What if I did this coupon
yeah,
multiple times? What if I voted 100 times? What would happen? Being able to really
yeah,
think these things through.
yeah. It feels like, and I don't want to put words in your mouth unless you like them. It feels like what you're advocating there for is threat modeling that incorporates business logic abuse, as one
Exactly.
of the threats. So yeah, update your threat modeling process to make sure it covers business logic abuse is a practical takeaway.
Exactly. And I think that goes back to that we need to focus on the fundamentals. None of this is, all that different than what we've been seeing forever. We just need to really focus on how these new threats can be related to what we already know about security and all the protections we already have in place.
Yeah. Yeah, so you don't I mean you don't need as a vendor it always hurts me to say this. You don't necessarily need a new tool here. What you need is to take a process that you have in place today around threat modeling and make sure that
Mhm.
that it's up to date with the current threats, business logic abuse in this case. And then
Mhm.
based on that threat modeling, you can decide what mitigation actions you need to take, whether it's a change in process, whether it's education, whether it's a tool. I'm going to bet money that part of what needs to be done there is educating developers about how to build APIs and applications that avoid business logic abuse. But
Exactly.
that should come out of the threat model ultimately.
Exactly.
Yeah. So the other item I wanted to touch base on here is this idea that API risk is outpacing traditional AppSec programs. And I think it's particularly relevant to you and the position you're in today. Does that ring true for you, or do you feel like that's not necessarily a reasonable conclusion to come to?
I think it's extremely reasonable, and I think it kind of goes back to not to steal all your promotion here, but the API security is that AI security is product security. It's all very much related, especially nowadays when there's so many attack vectors based off of API connections. It really is something that we're going to have to continue to focus on. It's not something that we can just put in its own little bucket. It's
Hmm.
extremely important because it has to do with all of these novel technologies that everyone wants to use.
So what changes for a traditional AppSec program? What needs to change in order to make sure that API risk isn't outpacing that program?
I would argue that not a whole lot has to change. There are some really fantastic tools out there that can help, get a better understanding of your attack surface, understand what exactly you're looking at. But again, it's really doing the basics right. Like we talked about with threat modeling. Threat modeling is something we've been doing forever, and that a lot of people really do understand, but we need to evolve the threat modeling process to keep up with new emerging threats. So if
Hmm.
we're doing a threat model to talk about specifically business logic or how a new API endpoint can be abused, or what risk that opening a new API endpoint would bring to the rest of the platform, I think that's extremely helpful.
Yeah, I mean, we're almost talking about sort of a set of dependencies here, or sort of nested dolls. You want to make sure that
Mhm,
you're doing threat modeling in the first place. That's a great starting
mhm,
point. If you're not, that threat modeling includes the technologies that you're deploying. So if you're deploying web applications, great. If you're deploying APIs, make sure they're included, and that
mhm.
you want to include business logic as sort of a next level, as an emerging threat that's coming. Although to a certain extent it's here as already. So there, it's almost a maturity level, right? So you could evaluate your AppSec program in terms of maturity levels for what it's addressing and where there are gaps.
Absolutely.
Yeah. So I don't want to leave out the other two key takeaways that we talked about. I think from the perspective of integration and trust chains, I think we largely talked about those. It's interesting because that is a conclusion that shows up mostly in the actual breaches and not in the vulnerability and exploit data, because the vulnerability and exploit data doesn't doesn't draw um, doesn't allow you to see connections between different companies. They're all atomic units, if you will. But it shows up
Mhm.
very strongly in the breach data that this is an area of concern, that organizations should pay attention to.
Absolutely, especially as you said, a lot of times you don't have a lot of insight into what's happening inside of these platforms or what they're doing with your data or your connections. So it's extremely important to understand how these other vendors are integrated with your product.
Yeah. And then the last one, maybe the obvious conclusion that AI and agent-backed APIs are already being exploited. I think we talked about that in a couple of different places. It does seem like an obvious conclusion with that massive growth of MCP vulnerabilities, and MCP as a technology. It's clear that we're seeing that attack surface expanding, and as we know, attackers will follow that attack surface for sure. Yeah. So that brings us to the last of the slides. If you have questions, as I said, feel free to pop them into the Q&A or put them in the LinkedIn comments, and we'll take a look at them. While you think about that and do that, I will tell you that you can actually get access to the report itself. So if you want to dive into more of the analysis and more of the detail behind what Jake and I just talked about, the report is available. There's a QR code, there's a link. You can also just find it on the Waller website, of course. And if you want to spend more time on threat modeling, and I swear we actually didn't plan to talk about threat modeling here and then have a webinar about threat modeling, but it worked out that way. The next
You're
webinar that we're
welcome.
planning is a CISO workshop on API threat modeling, with Bob Clinton, who's the field CTO at Driven.tech, and runs workshops on threat modeling. So I'm now more excited about that upcoming webinar than I was before we started, which is great.
Happy to help.
So let's take a look and see what we've got in terms of questions. I see, let's see, anyone in the LinkedIn chat? I don't see any questions there, and I don't see any in the Q&A. So I think we've covered everything at this point.
We did a
Uh,
great job.
just giving people a chance to pop in their last minute questions. But if not, I want to thank you, Jake, for joining me. I thought it was a great conversation, super interesting. Hope it was interesting for everyone else. And go take a look at the report and come join our next webinar, and let us know if you have questions for us after the fact.
Yeah,
Thanks,
thanks,
everyone.
Tim. It was a pleasure.